All right, welcome back to another Algebra 1. Today we are going to be comparing linear and exponential functions. If you'll turn with me to page 169, please. We'll be starting off on page 169. For today, I would recommend having your Desmos calculator open. Have both the graphing calculator and the scientific calculator today, because we're going to be working with both of those. So if you could have both of those open, that would be great, and that will help you out today. So we're going to be trying to tell linear functions from exponential functions from nothing functions. And the easiest way you can tell exponential function is that there is a exponent is variable. If it has a variable as an exponent, it is an exponential function. So if you look right here, y equals 3t, well, ding, 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 there's the exponential function. This one right here, y equals 19t plus 5, that is a linear function. And so we can actually double check both of those right here. Y equals 19, we're going to use x instead of t, just because that's what the calculator recognizes. So there is our linear function, y equals 19t plus 5. And then our other function, y equals 3, with the exponent of x, gives us an exponential function. So here you have blue is exponential, that's an exponential function, and then the red is a linear function. Okay. So now, let's see, right here, down at the bottom. How can you compare the growth rates of linear and exponential functions? Well, let's look at the growth rates. If you see, let's mellow this one out. Let's go like this. And then let's look at the function. So for this linear function, you see this constant growth rate. It's the same growth rate here as it is here, as it is here, as it is way down here. A linear function has a constant growth rate. However, this exponential function, here it's growing relatively slowly. Here it's growing a little bit faster, here it's growing faster still, and here it's growing incredibly fast. So a linear growth is constant. Now make sure you're filling out your workbook, your student journal, while I'm filling out mine, because that is part of your grade. So make sure it's filled out, have a picture of it in there too. And then exponential growth or decay is growing or decaying more rapidly further along it gets. So it starts growing, and you can see this growth. The growth is slow here, it's getting a little bit faster here, and faster, and then very fast. It's growing very quickly. Whereas the line, again, the growth rate here is the same as the growth rate here, same as the growth rate here. All right. Very nice. Which function has a growth rate that is eventually much greater than the growth rate of the other function? Exponential. Because it just keeps growing faster and faster. Growing faster and faster. Okay, you can pause it, make sure you get the definitions in there. Let's turn to page 170 and take a look. We have right here the average rate of change. Average rate of change is, and I hate to use the word in the definition, but I'm not sure how to avoid it. It's average rate over a certain time. So, for instance, if I wanted to, in this one, if I wanted to take the average rate of change from, say, this point to this point, it would be much different than the average rate of change from this point to this point. This rate of change would be fairly slow. The average rate of change would be fairly slow. Whereas here, the average rate of change would be fairly quick. All right. So here we have a linear function, y equals mx plus b. And here we have an exponential function, y equals ab to the exponent x. All right, well, let's get into our homework. For here, you're supposed to chart these and then tell whether it's an exponential function, a linear function, or neither. So I'll do the first one, and then you'll do the ones after this. So let's see, we have to go, our y value has to go up to 8 and down to 2. So we'll have our y values. Let's see, our x has to go -5, -3. So we'll do this. All right, -3, 2, 1, 2, 3, 1, 2. -2, 4, 1, 2, 1, 2, 3, 4. -4, 4, 1, 2, 3, 4, 1, 2, 3, 4. -1, 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. And -5, 8, 1, 2, 3, 4, 5, 8. What do we got here? Linear function? Definitely not. Exponential function? Actually, not quite. We actually have a parabola, which we'll get into that later. So that would be neither. So go ahead and graph these, plot all the points for 2, 3, and 4, and then tell me whether they are a linear function, an exponential function, or neither. All right. Moving on to number 5. Tell whether the table values represents linear or exponential function. So here's an interesting thing. Well, actually, I'll show you that in a bit. Let's look at the rate of change. First of all, these are constant. -1, -1, -1, -1. Great, check. How do I get from 7 to 4? Well, I subtract 3. 4 to 1, I subtract 3, subtract 3, subtract 3. So what does that tell us when we have addition or subtraction constant change? We have a constant change, which means it's linear. I'm going to go ahead and do this one, and then you'll do 7 and 8, and you can actually make, I like to make tables for these. But going back up to number 6, let's see the rate of change. That is times 6. Times 6. Each one of those is times 6. Now, an interesting way to do this, let's check this out. If you want to find the rate of change, I knew it was times 6 because from 2 to 12 is times 6. From 12 to 72 is times 6. So then I went back. 1/3 times 6 would be 6 over 3, which equals 2. So I was able to do that. Now, what you can do is you can get in here to the calculator, the scientific calculator, and you can go 2 divided by, and then we'll do, I should do parentheses because we have another fraction. 2 divided by 1/3. 1/3. 2 divided by 1/3 equals 6. There it is. 2 divided by 1/3 is 6, so 1/3 times 2 is 6. Same thing here, 12 divided by 2. If we did 12 divided by 2, we get our 6. And what about this? 1/3 let's do parentheses so we know it's 1/3 parentheses divided by 1/18. 1/18. There it is. We have 6. 1/3 divided by 1/18. So we know that this is times 6 each one. So there is a multiplication change. So this is exponential. Now what I would encourage you to do is chart these, or put these in a table. So let's start off -2, -4. I like the vertical tables because they help and they just make more sense in my head. So do that and then find the rate of change and see if you have a linear or an exponential rate of change. Number 8, I would do the same thing. Go ahead and make a table and then calculate your change. And if you need to, please use the scientific calculator to find out your rate of change. All right, a person invests into an account that earns compounding interest. Well, what we're going to do, table shows the amount after 1 year. So we have our equation, if you remember. Oops, let's move this up. We have our equation from yesterday, which says y equals our original amount 1 plus r time. So here we have our original amount. Oops, I'm not supposed to do this, but actually I'll get it started because we need to find out what is our rate of change. So what do we do? What goes on here? Well, that's plus 50, and that's plus 5250. And that's plus, well, that's plus 5563. So we're not getting a consistent rate of change through addition. Why don't we see what we get when we put this into the scientific calculator? And let's do 1215.51 divided by 1157.63. Okay, so I see a rate of change right there. Okay, I want to see if it's the same for this next one. 1157.63 divided by 1102.5. That's not quite the same. Actually, that's pretty darn close. I think I was off by 1,000th. So you're having a similar rate of change. So it's actually giving you your B value in there. So go ahead and do this and find your B value. Put your B value right into there. And then you'll have your equation. Okay, please email me, call me, give me any questions that you have for this. We can Zoom. I could walk you through it over the phone. Whatever you have, give me a call. Let's Zoom. Let's figure these out together. And go ahead and finish up 1 through 9 in the student journal, and then do the problems assigned in the extra practice in the math worksheet. All right, have a wonderful day. Bye.